So in talking about angle-angle similarity, we have gone ahead and put the theorem that we used on the previous slide onto this one. That way we can refer back to it. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are going to be similar. And the way we say that in math terms, if the measure of angle A, which we see down here, okay, the measure of angle A is congruent to the measure of angle D, and the measure of angle C is congruent to the measure of angle F, then triangle ABC is similar to triangle DEF. Now the question here, why don't we need to prove all three angles congruent? Why is only two pairs sufficient? It's because of the triangle sum theorem. If we know that A is congruent to D and C is congruent to F, if two pairs of angles are congruent to two pairs in another triangle, the third angle has to be congruent no matter what, because we know that A, B, and C are all going to add to 180. D, F, and E are all going to add up to equal 180. Okay, then we can determine that that missing angle that we're not accounting for has to equal the same thing if the other two angles equal each other. So because of that, we can skip needing to know that third angle. So in this case, down here at the bottom, explain how you know these triangles are similar. They're congruent by the angle-angle similarity theorem. We have two corresponding angles that are congruent. We have got a 52-degree in both, okay, as we can see here. And then we've got an 83-degree in both, which we can see there. I'll actually do it on the inside just to make it a little bit cleaner, okay. And we only need two because the triangle sum theorem says that no matter what, excuse that, 180 minus 52 minus 83, this is going to be 45 no matter which one we're looking at, okay? So that has to be 45 no matter what. So we can use that information when we're determining if triangles are similar by the angle-angle similarity, similar by angle-angle similarity. So in this case, we have triangles ABC and triangles DEF. And essentially, we need to prove that either angle C equals 31 degrees or angle E equals 74 degrees. So either C equals 31 or E equals 74. And I'll go ahead and use blue here. Okay. And if either one of those works, then yeah, it's going to be congruent or similar, excuse me. But if they don't, then it might not. So let's go on ahead. I'm going to do both just so that we can double check our work. We've got 74 plus 75 plus angle C. That's got to equal 180 degrees. We know that. So 74 plus 75 is 149 plus angle C equals 180. And then if I subtract 149 from both sides, angle C equals 180. 180 minus 149, 31 degrees. So right now it looks like they are similar by angle-angle because I know that this angle is congruent to this angle, and I already know that 75 is congruent in both. So I could essentially write the similarity statement right now. Yes, by angle-angle similarity, triangle ABC is similar to triangle DEF. But I'm going to go on ahead a step further and double check my work. So I know that 75 plus 31 plus angle E needs to equal 180 degrees. 75 plus 31 equals 106 plus angle E equals 180. 180 minus 106. Angle E equals 74, which is what we need it to equal. So either way we look at it, we are similar by angle-angle similarity. Down here at the bottom, determine if the triangles below are similar by angle-angle similarity, and if so, write the similarity statement. We already know that angle V and angle Y are congruent to each other because that was given to us. And I can skip a couple steps because if we remember, we've talked about vertical angles all year long, but this angle right here, angle WXV and angle YXZ are congruent by vertical angles. Okay, they're two angles that only share the vertex at angle X, so they are congruent. Therefore, so these are congruent by vertical angles, vertical angle theorem. Okay, so because of that, we know that they are similar by angle similarity. We know that triangle, and we can pick whichever we want. Let's go V, then X in the middle, W is similar to what's congruent to V. We know it's Y, X and X, and then Z by itself. Okay, and that covers our angle similarity topic.